Hi, everyone, and welcome to our first e-learning video on sequences. Our first section is going to have digital homework tonight. Author in action videos are accessible. There's a PDF you can print out of the notes, and anywhere you see a little asterisk can be watched by the author in action. And I will go through a couple videos with that. Keeping in mind, this is my first time making a lot of videos for teaching e-learning. So hopefully they'll get better as we go along, but this is my kind of debut on that. So our first one is, what is a sequence? A sequence, it deals with a sequence of events. This is what we're used to hearing it as, so first, second, third, and so forth. The definition of a sequence is a function whose domain is positive integers, so no zeros, no fractions, no decimals, but 0, 1, 2, 3, 4, no, excuse me, 1, 2, 3, 4, and so forth. This first example is not on the guided notes. It's just kind of a completed one to show you how basic the first, 6 terms are. So there's an algebraic solution. You would just plug in, the first 6 terms. So you can't plug in decimals. It only can be in integers. So you would plug in a 1, and you get 1 minus 1 over 1, and then plug in 2, and so forth. So you should get the first 6 terms are 0, 1/2, 2/3, 3/4, 4/5, and 5/6. So not really looking for you to complete that, but just you're plugging in 1, you're plugging in 2, and all the way up is integers. All right. So and then you can graph them. I'm not looking for perfect graphs right now, just kind of a general shape. Is it taking on a cubic, a quartic, a linear, exponential? What is going on with that pattern? So this one tends to be curving off and rounding off. It actually has, it's a rational function. If you look at it, n minus 1 over n. So it has a horizontal asymptote of 1. So these fractions are actually curving down towards 1 if you understand the original function. So that's kind of interesting piece of that. All right, here's our first 3 examples. I encourage you to pause the video and try them on your own, plugging in 1 through 6. I have here some just organization of lines and naming the number sequence underneath it, just so you can see that. Just to organize it. That's optional, but it helps a lot of students. So I'm going to encourage, again, you pause this and try these 3 on your own. Okay, so our first one, we would just plug in 1 in for n in the 2 locations, and we get 1 squared divided by 2 times 1 plus 1 should become 1/3. And then when we repeat those, we should get these fractions ending in 36 over 13. All I'm looking for as a sketch is kind of saying what's the general shape as time goes by, or as the n increases by integer values. And this one's increasing, but in an exponential pattern almost, not, again, not in a linear way, okay? All right, our next example, b sub n, you're gonna plug in 1. So this one is a pattern that you'll start seeing kind of come up throughout the chapter. -1 to the nth, and then 2 times 1. All right, so that right there is going to be going to kind of produce the first one, which is going to be -2. Let me erase that because I have something popping up here. And then you're going to plug in 2, 3, and you should get rotating or alternating negative, positive, even numbers. So the next problem should be 14 and negative, and then 16 and then positive. So once you start establishing the pattern, you may not need to plug it into the formula very much. Okay, our last one here is n being even and odds, which is kind of a piecewise function. So if it's even, we're going to have certain pieces and odds. So it might help to plug in the odds first and then the evens, and also draw out 6 little bars. So you should get 1, 4, 3, 16, 5, 36. So notice the 1, 3, 5 are the odd parts of that. Okay,